Hello, everyone. Welcome to Teammate Solutions Master Series of webinars. The entire series deals with building software solutions in a practical and reliable fashions, helping everyone implementing some standard operating procedures and best practices. In this seminar, we deal with one of the very first problems we have. As a business manager or as a product manager, you want to solve a business problem. You have an idea such as, for my enterprise, I need to implement a solution to solve a particular ERP problem or a human resources problem or an e-commerce problem. Once you have an idea, what are the right steps in ensuring that the software solution that is built ultimately meets the problem, solves the problem without missing even a little bit? How do you ensure that the entire development, support, marketing, and all the other functional teams understand the business problem in an action-oriented way, in a way they can translate the requirements into something they need to do so that the product that is built ultimately solves the problem we intend to solve. At Teammate, Subhash and I have been building solutions for a few decades now. We have built for our own companies as well as for our clients, starting from completely a concept stage and taking them all the way to the product launch, sometimes with great success and a few times making our mistakes. But overall, we have learned so much that we want to capture here and help everyone with what we have learned. So let us deal with the first problem that we talk about. While I do it, I want to invite Subhash into the conversation. Subhash leads all the technology, architecture, and anything to do with the actual development at Teammate Solutions. Together, we have had great success in building products for people that are technical as well as completely non-technical. So Subhash, please join the conversation. And if you may, can you actually tell us why this problem of capturing and defining a business problem is important to actually build a software solution that succeeds? Why can't we just go talk about it or write a simple document and go about it? Why is this problem significant, and what do we know about this?
Hey, thanks for inviting me, Sinu. That's a valid question, right? Most of us worry about how to build software, not what to build. Writing business problems, or as we call them, specifications, is a trivial matter, isn't it? And over a period of time, we have managed to solve the problem as well. It's not like business requirements have been ever difficult to nail down in the past, or were they? Let's talk about requirements itself and why they are hard. Let's take one simple example of the fact that most products are long living, anywhere between 3 to 5 years, from inception stage to all the way to reaching customers and reaching sunset. You can clearly identify some aspects of this life cycle, like the phases. Usually there are 4 different phases, whether everybody follows them in the same order or they break it down or they jump from one to another directly. That's left to product individually, but most products share these 4 phases. And let's dive into each of these 4 phases and understand why. Taking even a trivial example like the product life cycle, we can understand and see that requirements are not a simple ballgame. Let's take ideation first. Ideation is all about translating something that is in your mind into something that works. The model that you think is present in reality and what you want to change in reality is something that you want to produce in software. And there are a series of translation of this model that happen during this time. The reality model is first of all translated into a document form, usually by a product owner or a product manager, who then hands it over to the developer, who does another translation of the specification that is given to him and codes into the software, which is then exposed to the external world in a computing environment on a cloud platform, for example. And there's a feedback loop going on. The moment you expose it to the external world, there's feedback that is going to come and you have to enrich your model. So there's an ongoing loop of the model that is being translated across layers, which is not necessarily nailed down because you're just in the ideation phase. You don't have time or resources to nail documentation down, right? Let's take the next step of development. Here, the main goal is to provide input to the development team to produce something useful. And these are provided in the form of different kinds of artifacts. It could be a UX document, which tells how the user interface looks. It could be business rules and workflows, followed by personas that are modeled in the backend of the product. And over a period of time, these requirements don't stay siloed, they start feeding off each other. So you will end up with a product which is depicted in many different artifacts, but no artifact is the single source of truth. You cannot go to any of them and ask, what does the system do today? What is my system functionality? So requirements, though they appear as if they're all organized in the beginning, tend to get into a chaotic mode over a period of time. Growth is the next exciting phase for every product, where after the initial spurt of development, people are scaling up. More users, more domains, more features, more use cases. The goal here is to provide as much functionality as possible with as many knobs as possible to end users. And to do that, you tend to grow the team, add more team members, spread it across different development centers. So documentation becomes important, stability becomes important, quality becomes important. So there's a lot of focus on how requirements are structured and given to people. There's a lot more discipline that goes into the process of identifying requirements, translating them into development, and then verifying whether the development actually delivered the value. The last phase is maintenance. Yes, there are not many features being built here, but the focus is entirely on documentation because this is where a product lives for a long time and team members will change, domains will change, market cases will change. But you need to remember with the changing seasons what the product was intended to do in the first place. What does it really contain? What did we learn in the past? What have we not done yet in the product that we want to do in the future? There's a lot of documentation and knowledge maintenance that goes into this phase, wherein requirements fits in as well. The original requirements now become documentation actually in a different format. And if they are not modeled properly, the system and the documentation tend to diverge. The system does something and the documentation says entirely something else. So there's no single source of truth again that can be derived from this state of knowledge.
Thank you, Subhash. It seems that the importance of capturing and defining the business problem in such a way that everybody understands is important not only to deliver the initial product, but it matters throughout the life cycle of a product. Even if you succeed, let's say to build your MVP or the initial product, by luck, it must be luck if you really do it without a proper approach. You describe the problem and people gather around and build a product, voila, it actually solves the problem. The problem is not done yet. You may still encounter very significant problems, and as the product evolves from the initial phase through rest of its phases, you may still go away from what you intend to do, and the usefulness of the product over a period of time becomes less and less. So thank you for sharing that. we also understand from this that whatever the approach is, the most important thing to do is actually take it into consciousness, make it a very, very conscious effort that we need an approach. We need to focus on defining the problem and capturing what makes a solution address this problem in some format that is useful for throughout the life cycle of the product. Bringing that into consciousness and making it an effort for everyone is the most important aspect in making sure the product becomes successful. Now that you have shared that, Subhash, can you please share what's an approach we all can use without having in-depth technical expertise or getting a computer science degree? What is an approach that everyone, whether you have a business experience, technical experience, it does not matter. What is an approach we can reliably use that others can join in and ensure that the problem and the solution map to each other?
Let's start with the ideal qualities we would want to have seen in documentation or in the requirements rather. What do we want from an ideal requirements gathering process that will help us sustain forever? It should be easy to remember. The requirements should be organized in such a way that we can recollect them very easily. And we know that the best way to organize for recollection is in the form of stories. We have been doing that for ages between ourselves on fireside chats. But when you organize even a mundane requirement in the form of a story, most people tend to remember it and tend to understand the meaning or the concept behind it easily. It should also be effortless to capture. We want to involve as many people as possible in the requirement gathering process. It should be as simple as a single whiteboard where people stand around and use sticky notes to outline the requirement. It should be temporal. There should be a workflow inherently involved where the workflow starts at one point, at a point in time, and progresses forward. Much easier to recollect that way, as long as the flow is coherent and understood by everybody. We are putting in so much effort into requirement gathering. Why not use it to get to development as well? Why should it remain as a siloed, separate document over a period of time? We want it to be integrated into the development structure itself. So whatever we generate as output should actually lead to code by itself. And most important of all, it should be simple to maintain. If it is not, over a period of time, as pressure increases on the product and people come and go and knowledge is lost in the middle, the process itself falls to the wayside. Nobody will remember the intent or the original purpose of setting up the process in the first place. So, what could a method be that fits into all these categories? By trial and error, we have tried different aspects, and you see many of them doing it in the wild. Long form documents, individual stories, UX driven approaches. But we believe that a coherent and a sustainable process is surrounded by one that is centered around events. So, what is an event? Let me explain what an event is and follow it up with an example. An event is something that is happening in the wild, in the environment, that is of importance to me. It is significant to note that it should be of importance to me because my system deals with something specific. If I'm a loan management system, I want to care about disbursals that happen in the environment or payments that come in the environment. If I'm a HR system, I want to care about applications being submitted towards job creation. So the kind of events that one targets is important. So something is happening in the environment and the system is being brought in sync with whatever happened in the environment. Let's stick to the definition of event and then see how that changes and enhances as we give some examples. Let's start with one that everybody understands nowadays: ordering items online on an online platform like Amazon. We start off by adding products that we want into a cart, check them out and pay for them. Once the order is placed, somebody in some warehouse in a distant corner of the country notices the order, ships the item, and once the item reaches me, marks the order as fulfilled. This is such a coherent mechanism of depicting what happens from start to finish when an order is placed. And it's very difficult to forget this. Anybody who understands the sequence can easily recollect it over a period of time. Let's go back to our qualities discussion and merge some aspects to this order fulfillment example. This flow, as you can see, is harder to misrepresent. You cannot miss out on a step. You cannot introduce steps in the middle. Wherever you are, you know exactly what the flow is, and when you convey it to somebody else, they will exactly be on the same page as you. It's harder to confuse yourself. It's workflow oriented, so it's easier to recollect. You know what happens first and what happens next. You know the order. So if you are seeing an order with the status of paid, you know that there are 3 steps that have been completed and 3 steps are pending. So it's workflow oriented. And it is responding to a change to the environment. The first change that happened in the environment was the user's intent to place products into a cart. The system synced to it. Then he decides to check out and pay for them. The system comes into cognizance with those events. Then the ordering, shipping, and fulfillments, whenever they happen, the system is brought into sync with those environmental changes. So you see that the system is just mirroring whatever happens in the environment in the closest way possible. That's where a domain model comes into play. We want to write code that models the realistic environment as closely as possible. That way, not only business users, but also developers can clearly see what is happening and what should happen. When you create 2 different models, one that is in reality that business people, product owners, and non-techies understand, and one that is in code which developers understand, there's a translation that needs to come in between these 2 layers, and it tends to break down understanding and prevent people being on the same page as the product grows. Let's explode with another example, a particular event that happens and the surrounding aspects to understand better. Let's this time take the event of a user registering on an online platform. Now, it doesn't matter. Remember that the user registered through his Facebook account or Twitter account or through a normal email ID, email address, password. What matters is that a user registered and we want to take cognizance of that event. Now, somehow the user got registered and there was probably a user interface that led him to register, right? So that would be the second step of understanding. This event was triggered from a user interface, and when we see the user interface, we can know what kind of input was provided. In our case, there's a name, email address, and a password that are being provided as input. Something needs to map from this front end, from the user interface to the event itself, which is acting like a checking process, and we'll expand that a little more. But somebody needs to act as a middleman, translating what was entered in the UI to the event, and that is what we call a command. In this case, it will be the sign up command, and it's just a carrier of the message that was entered in the front end. Now, this step is very important because the user has expressed an intent to register by entering his name, email address, and password and clicking on a button. The system has to take cognizance of it and come to the same state. It has to accept the user and create a record of him in the system. Now, whether the user can proceed or not is dependent on whether the command goes through successfully. That is the most important aspect of a command. When the command comes into the system verifies whether the command should be let in and the event generated. In this case, just as an example, if the user is already registered and if he tries to register again by giving his email ID, then the command processing should fail. The system should not accept the command that was given by the user. So the system will not come to an erroneous state because there should not be 2 records in the database with the email address repeating. So the command acts as the checking mechanism where all the validations, etc., are being placed. Now, once the input has come, we want to show the outside world that something has happened. I processed the order, I processed the user sign up event and did something. That is what we call a view, and that is usually the depiction of whatever has happened within the system. Now, it could be just data. An administrator might be observing the report of all users who have signed up, and he might see a new record appear. Or it might be an email which the user receives after signing in because he needs to complete after registering because he needs to complete the verification process. So the view itself can be of different forms, but that happens in reply, in response to the event being registered in the system. So hopefully this clarifies a bit of how the process evolves by keeping the event at the center. And we'll see more in the coming slides. But this, in brief, captures a single unit of the whole event model, where an event is accepted from the environment in the form of some kind of input and processed if all validations, if all the entire state of the system is in sync, and then an effect is produced which tells that the system processed the event.
Thank you, Subhash. In the last section, you talked about why focusing on this process of capturing business requirements is very, very important to build a system that succeeds in answering those requirements. Now, in this section, you wanted to present an approach that helps us on how to capture those requirements. Before you did that, you said, what would actually make a good approach? What are the characteristics of a good system that actually easily captures the requirements without adding more work and more complications to this process of capturing business requirements? Meaning it has to be simple. It has to be a derivative of the everyday work we do as we build the system. It is something that everyone in the team can adopt. Everyone in the team can contribute to. And after you described those requirements, you presented a system where events work as the foundation or as building blocks to build a good system that can capture the systems. You also explained what this event is and how a system built on top of these events, on these little Legos, would actually capture the business problem in a more structured and usable way, how we can put the whole thing into operation. That seems so far very clear. It also is clear that if there is some other system that can do the same, as long as it meets those requirements, as long as it helps everybody to keep always in sync between the business problem and the execution, it's all good. Now that we understand what an event is, how the whole thing works, can you actually take an example and walk us through, imagine I'm a business manager or a product manager, and where would I start? How do I put this system in place? What are the tools I need? If you can take a common example and walk us through, that will be really helpful.
Sure, let's take the often used example of going to a movie. Imagine that we are booking online for tickets to a movie that we want to go to. Let's start with events surrounding this workflow and then continue organizing those events in some form to give us the requirements that we are looking for. There are a series of steps that follow identifying the events, and then we'll step through them one by one as we go. But what are the events that happen when you want to book a movie ticket? Before even coming to booking the movie should have been exposed on the theater portal, right? So there are aspects that involve the theater management, which actually adds the movie to the theater's ongoing shows, identifies screens that they can show in, and show timings. Once that is available, a user lands upon the theater portal and identifies which movie that he wants to go to, selects seats, and confirms that the seat selection is correct and everything else is okay, and then pays and gets the confirmation in the form of a ticket which contains a barcode. So these are all events that happen when we go through this workflow. Imagine that we are standing on a whiteboard, and people are just coming up with these events and taking stickies and writing them on sticky notes and sticking them on the board. As a next step, let's lay these events out in some form of a timeline, starting with what happens first, followed by what uh, happens next. So, like we discussed initially, first of all, the theater should have added the movie to their roster and exposed it as a show that is available. That's probably the left of the screen. And what follows are the steps that the individual user takes in getting to the payment screen and then getting the ticket for the movie. So you've just organized these events on a horizontal timeline, and time is flowing from left to right. Let's pick one example in this of the seat selection process and the payment process and explore further, drill down further. Now, once we have identified these events, there are some inputs being provided from the user interface to generate these events, like we have been speaking, right? So, what does a seat selection event input look like? And we have seen this many times. There's usually a screen where the theater layout is shown, and you have to select individual seats, right? That would be the input for the seat selected event. We'll talk about how the input is transferred as a next step, but we are in this stage identifying what does it look like from a user point of view, where the input is given to generate the event. The next kind of screen that will initiate the payment activity is a confirmation screen, where just a simple information display of what movie was selected and what seats were selected is shown, along with probably a payment option. Do you want to pay by credit card, or do you want to pay by some other kind of token, is probably displayed in the screen. There's also a background activity that goes on in the payment itself, where my credit card is being charged if I've chosen to pay by that option. So let's represent that also as a mechanism that generates an event at the end of a successful run, which would be payment completed. And once the whole process is completed, the user sees the information display on the screen for the ticket, which contains a barcode, and probably he receives an email with a PDF with the same barcode, right? So that is sent to the user, which is then used when the user visits the movie theater at the right time. Probably there's a scanner that accepts the barcode and marks the ticket as used. So these are all input screens that are connected to the event. So you now see that we've actually created a visual workflow of the events that happen in the background. What connect these visual workflows to events? Commands. And these commands are doing nothing but translating the value that was entered in the front end to something that is accepted by the event. Also remember that it's this place where all the validations and checkpoints are before generating the event. Let me give you an example of where it could fail. I've selected a seat, and in the meantime, somebody else has selected the same seat and completed the payment. Should I be allowed to select the same seat? Obviously not. So the system has to refuse to process the command of selecting a seat and not generate a new seat selected event. That logic applies across the board. Whenever some input comes into the system takes the command, but checks if the command can be processed without violating any of the constraints. If anything is going to be violated in terms of a business rule or a validation, then this command is not processed and the event is not accepted. And as we spoke, once the event is accepted, the system has to tell the external world that something has happened. So in case of a seat selection process, the next screen that would be shown is the confirmation screen, where the system tells that, hey, I have booked 2 seats for you, but I'm going to reserve them for you only for the next 15 minutes. And probably there's a timer shown. So the system is confirming that its internal state has been synced with the user's intent and is conveying that in the form of an information display. This again applies across the board, and At the end of every event, maybe, most of the times, there is something that is generated that tells the rest of the world that something has happened. In rare cases, there is nothing that is generated, but for example, if the user has used the ticket, that's it, right? He just goes into the theater and continues with whatever he's watching. But there's no information display required after the ticket has been used. So sometimes there are no views attached to events, but many times the system has to tell the external world that something has been processed successfully. So now you see, starting with the events, we derived the visual workflow and we connected the visual workflow to an event. And while connecting it, we came up with business rules and validations that have to be processed for the system to accept the input that was given in the front end. And once the event is accepted, we are also identifying how does the system convey its state change to the rest of the world. Now that we have organized this workflow, we want it to be handed over to the development team. And what better way than to convert it in some form of specifications that can be used to drive development. There's a model called behavioral driven development where people can write requirements in the form of English statements, but they're also usable as test cases in code. If you were to follow that model, then the feature of going to a movie and wanting to go to a movie and selecting a seat would be the epic, but there will be a lot of scenarios in that feature that would identify straightforward paths where the command is accepted and negative paths where the command should be rejected. As an example, in this case that you see, if the seat is selected already, then the user should not be allowed to reserve it again. Or if the seat was selected, but the payment did not go through within a specific amount of time, the seat has to be released. These are all scenarios of the feature of selecting seats, and these are organized in the form of specs, which are then added to a ticketing tool that you use to manage development, like Jira or Trello. And from then onwards, the development takes over. But the sync between the requirements that were generated is maintained, is managed, is preserved when the development happens. You have to remember that this process can seem long-winded when somebody can write a single paragraph and convey what they want the system to do. But over a period of time, statements or documents tend to go out of scope. They tend to change, and the system no longer reflects what was written in the documentation. So what we call as you go approaches, where things are written and done ad hoc, tend to get complicated over a period of time. And they tend to get so complicated that you can hit a glass wall in terms of changes. When you change something in the system, there can be a ripple effect that is produced throughout the system, which will prevent you from making forward progress. But if you are cognizant about such complexities that might happen, if you are not organized enough from day one, you can take steps to limit the complexity. Event-based approaches are one mechanism that provide a very good effort to output ratio, even though the complexity increases over a period of time slightly because the system is handling many things. It does not loop towards infinity. It doesn't become infinite in terms of complexity scale because we are controlling and managing requirements in an effective way.
Thank you, Subhash. Just to go over the last section, you have taken an example and walked through how a business manager or a product manager will start out first, brainstorming the events and coming up with a timeline on how those events take place, and creating a storyboard with proper input and output, and eventually scaling up, bringing everybody in the team into the process so everybody can do their process. It looks to me that it's quite easy to follow, and everyone takes advantage of it. Just going over the entire topic that we discussed today, it is so important. I cannot stress this enough. It is so important that once you have a vision, or once you have a very high level idea of how to solve a business problem using a software system, you have an approach, you take into so strongly into the consciousness and operationalize that you need to translate those requirements, that vision, into what people can build and solve the problem with, and focus on that approach. And there are many approaches. We have tried ourselves so many approaches. One approach that seems to work is starting out with events. Take event as a building block, a foundation, and the rest of the pieces in that system fall around events, fulfilling it. And once you come up with a bunch of events, you develop a timeline, and that helps you develop the storyline, and with clear input and output for these events, and eventually you have a system. From our own experience, we have tried numerous ways. We have demanded very detailed and highly specific product requirement documents a while ago. The whole industry was big on that. And later on, with the entire evolution of some of the software practices and agile and many things, we moved away from that. And we went to, okay, let's come up with a UI first or a UX first, and then we'll go develop the system. You just tell me your vision, like a UI or UX or wireframes. We can go from there. That also left much to be desired. And now we figured out no one particular approach that we had tried before would exactly solve this, but you need to pull them together around a concept that really holds the synchronization between the business problem and the software being developed throughout the product lifecycle. Because the vision itself may change, the product keeps evolving, product keeps going stage to stage. So that would be around events. This does not replace, it substantiates. You can continue to do other things to really ensure that you are increasing the asset value of software you're building. And every day, with every action you take, you are going 1 inch further in absolutely reflecting the business problem in the software. Hopefully it has been helpful, and we'll take question and answers offline. And if you want further information on this or some references, please visit teammatesolutions.com. And you are also welcome to send us an email message. And we wish you great success in your product development and building absolutely world's best software tools. Thank you.
Thank you, Sri.